After that last page, I hope that we have a little break on this one. 16b, increasing and decreasing functions. Show the interval of numbers greater than or equal to 2 using the algebraic and geometric forms from the book. Okay. So in algebra, you would just say x is greater than or equal to 2. In geometry, for one dimension, you would use a number line, and then you would mark the number 2. And then you would say, oh, the number is greater than or equal to 2 would be these numbers. And you would make a dot that's colored in for the 2 to show that 2 is also included. Okay. Suppose S is an interval in the domain of f of x, so that f of x is defined for all x in the interval S. F of x is increasing on S means that, and this is like if and only if, and so it's like a definition, f of A is less than or equal to f of B for all A and B in S, such that A is less than B, blah, blah, blah. F of x is decreasing if f of A is greater than or equal to, okay. So basically they're just saying that, like, oh, you define an interval that's that long. It's S, by the way. And it's easy to draw a constantly decreasing function or a constantly increasing function. Within the interval S, it's constantly decreasing or constantly increasing. But like when you try to like write it mathematically, it turns into this messy thing here. It says, hey, look, the number, you pick any two numbers on here, and A, which is on the left, and B, which is on the right, A is always going to be bigger than B, or A is always going to be smaller than B, depending on if it's increasing or decreasing. So that's all they're saying there. Okay, sketch here a function which increases on the interval x is less than or equal to 0, and decreases on the interval x is greater than or equal to 0. So that means like on this, the positive half, it's the function is decreasing. So let's draw it decreasing. And then on the negative interval, the function is increasing. So it would look something like that. It would increase, and then it gets to the y-axis, and then it decreases. Okay, something like that. It's kind of like a normal curve. Okay. Now, let's see. If we know that f of x is increasing on the interval s, then we know that the derivative of f is positive. Okay? Positive, greater than or equal to 0. What if f of x is strictly increasing on s? Then we would say that f prime of x is greater than 0. It's always increasing, instead of like, oh, it's either increasing or staying the same. What about if it's decreasing? Then we say that the derivative is negative or 0, right? Because we didn't say strictly decreasing. If we say strictly decreasing, then we're going to say the derivative is negative or less than 0. Okay. What is the interval s for a monotone increasing function? Monotone increasing function means that it's increasing forever. In that case, the s is basically like, all numbers. So it's going to be like, it's going to be like all s. So you could say like x is a set of real numbers or something like that. Okay. Write the sign diagram for the derivative of f of x equals x squared. So for this one, the derivative of x squared is 2x, right? So this is a pretty, I have a nice line there to use for the sign diagram. So I'm going to make a sign diagram here. When x is 0, the value of the derivative is 0. And when x is positive, then the derivative is positive. And when x is negative, the derivative is negative. Okay? So that is the sign diagram for the derivative of x squared. And that makes sense, right? Take a look at the x squared. X squared is a parabola. So to the left of 0, it is decreasing. To the right of 0, it is increasing. So this totally makes sense, right? Okay. Mark with a different color the part of the sign diagram in which the function is increasing. Okay, so I'm going to mark it green. Okay. Give an example of a monotone increasing function. Monotone increasing function. So, do you see this function here? I would say it's something like e to the x. E to the x is constantly increasing from left to right. Okay. When classifying intervals of a function as increasing or decreasing, show how you will label a vertical asymptote on a sign diagram. Okay, so I'm going to make a sign diagram again. And then, remember, like, a 0 looks like that. Asymptote, we do like that. It looks like an asymptote, okay? So, like, we could say, oh, here it's positive, here it's negative, here it's positive too. And you see, like, right here, it's an asymptote, okay? So this is the asymptote, right there. Okay. All right. Oh, okay, there's only one exercise here. Just write down the intervals where the graphs are increasing or decreasing. Write down the intervals where the graphs are increasing or decreasing. Okay. So here, for sure, I'm gonna mark the increasing positive and decreasing negative. So this one is all positive. This one is all positive. This one is negative. Then it goes positive, and then it goes negative. Oops. You know what I'm going to do? I'm going to color the part that's positive green. And then I'll color the part that's negative red. 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 Okay, and I think the rest are green. Like that's green. It's growing. 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 Okay? Oh, growing here. Alright. Now I'm going to write all the intervals. So first I'm going to write all the intervals that are actually growing. I'm going to write it in green. So for this first one, it's on the origin. So it would be x is greater than or equal to 0. This one would be all real number x. This one here would be x is less than, let's see, 1 is less than or equal to x is less than or equal to 5. This one here would be x is less than or equal to 2. This one here would be x is greater than or equal to 2. Actually, let's rewrite this one because there's an asymptote. So we'll say x is greater than or equal to 2. It's less than 4. And x is greater than 4. Okay. Now let's do all the red ones. So like here, it would be x is greater than negative 2 and less than 3. And then here it would be x is less than 1. And here's x then greater than or equal to 5. Oh, this is less than or equal to 1. And then what about this one here? It's x is greater than or equal to 3. This one here, it's going to be x is less than 0. And this one here is x is zero is less than x is less than or equal to 2. Okay. So that's it. Wow, that was a quick one. Thank God.